Because it's easy if we assume a world where all the units move in the same way, right? In which case we can cache all the edges. Are we just going to assume that we don't cache these edge costs ever? Maybe I should do that. This means that this won't be the fastest pathfinding system for certain scenarios, but it's the best for a Civ type thing. If you're building a game where the movement cost to enter a tile is always the same for all units, then you can just store the cost as a float, right? You don't have to do... You just store, you know, this is the cost. Or if in graph theory, this is really the weight, right? The weight of this edge. But if we just assume that what we're doing here is always going to be this dynamic thing, maybe we can figure out a way to implement some caching for these costs later if that's a feature that we want. Okay, I think you know what we're gonna yeah, it's probably is premature optimization. We're just gonna assume all the time that we're gonna run this crap as is. So this tile graph, I don't want it to know what our unit is. I don't want to say, like, it doesn't need to know. So the edge is literally just going to be defined as tile A to tile B. That's it. At which point, do we really need to make a graph? I mean, really what it is, it's about saving the neighbors. So it's almost more like what we're actually doing here. The graph's job, in this particular scenario, the graph's job is to keep a list of all neighbors leaving a tile. Right? And in our scenario, most tiles are going to have 6 neighbors. If our world isn't cylindrical north and south, then the tiles literally at the north and south are going to have fewer neighbors. They only have 4 neighbors each. And that's something we don't want to have to recalculate. That is something you absolutely 100% have to cache. And really that's what it is. So it's kind of like this thing is going to contain something like this. It's kind of going to be a dictionary. Oh, yeah, I was going to say, have the refactor little... Oh, create class, really? Because it's just using system.collections.generic. It's going to be a dictionary where the key is going to be tile, and the value is going to be an array of tiles. Such that you can ask, don't set a breakpoint, must provide, what are you not happy about? Oh, there we go. Such that you can say something like, for our graph, like get neighbors from this tile. Because we can do that, because get neighbors is going to be here, unless this should just cache here. Do we need this graph at all? What the hell is the job of a graph anymore? I mean, normally what you would be doing is you would be stuffing all the tile info inside of some sort of node container. Yeah, no, you do need that because you need to know, right, sorry, we still need the node container. Because the node needs to know, shit, sorry. I think we're good. Let me come back to this. Let's close this without saving. Let's get rid of the tile graph. Remove it for the project. I think we're going to be okay. So we'll just have the neighbors cache themselves on the fly. So let's go back to our A star over here. So normally at this point, or over here, there might be the question of, do we need to explicitly create a graph? We'll come back to it. I don't think so. Okay. So, pathfinding. So, I'm going to be basically copying exactly what we have before in the Project Porcupine, but wording things for our current stuff and also making it more generic. So we are going to have some sort of a list of all of our nodes. Okay, it's some sort of container for all of our nodes. Do we duplicate nodes? Do we need anything like that? No, I think we're okay. We've got the start tile. We don't ever have to do anything about that. So we can go right to starting up on the hash set. So we need one array of our iPath tiles. One sort of thing. Hash set ensures that this is unique. It's like an array, but it's always guaranteed to be unique. Then this is going to be called the closed set, which is going to be a new hash set that starts out empty. We don't have to explicitly create the open set. The open set will be the list of, well, all nodes, right, at the start. So let's see here. We have the open set, which has to be a priority queue. Yes. Okay, we need a priority queue. Now this is definitely something we shouldn't have to write, assuming I've got a generic form of it in here, but I'm not sure that we do. Excellent, we do. This is just based on some other code we found somewhere, I think. So I'm going to grab this as is. Grab the raw. Grab this. It shouldn't have to be called pathfinding priority queue. Shouldn't it just be able to be called priority queue? It's also really annoying that in the version of C# that we're working with here, there's not a built-in priority queue data type, which I find very annoying. I don't know why it doesn't have one. Using priority queue. So it's got... There it is. Where did I grab this from? Ah. So we can just yank this in as is if I just downloaded this. So a priority queue is a type of it's a type of data set, like a list or dictionary or whatever, but you don't just feed it in an item for the list, you also have to feed in a number to represent its priority. In this case, for the pathfinding system, the priority number represents the length of that path. And it auto sort of sorts that list based on that priority number, which means you can always grab, say, the tile with the shortest distance from the top of the list in a very, very, very handy way. So I just want to download... GitHub's got an easy tool for that, isn't there? To just download a project. Don't it? I guess I'll just have to clone it or something. That's kind of annoying. GitHub must have a button to download something. Go into releases. There's not... I'm actually not on the proper page for it. That's what's going on. I'm not on the actual page for that project. There we go. If I grab that, clone or download, download a zip. There you go. Sorry about that. Boop, 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 boop. I was looking at the version in our project Porcupine. I need to open this in Explorer. That way I can grab this, drop that in there. And now I've got priority queue in here, and hopefully it'll just work just fine. Excellent. That's pathfinding priority queue. Okay. Now, there's going to be some complaints here because some of this code was written to use a different using Unity engine, a different debugger node. Okay, there we go. So we don't have to write that code. None of that code should be something we have to worry about writing at all, is the idea. What we have, though, is for our open set. Am I in the right code here? Excellent. For our open set, we're going to be using the pathfinding priority queue instead of this hash set. And we're going to tell it that, yeah, you are going to be using these IQ path tiles. So the open set is going to be a list of these. But this queue is really easy to use. You just, when you enqueue something, so when you create it, you can enqueue some tile, and you give it a number as the priority. And then when you do your dequeue operation, it just grabs the tile that is at the top of that queue, and it keeps it organized. I think it uses a binary tree internally, so everything is very, very quick, very, very well organized. It's important that the open set of all of our tiles is organized based on shortest distance first. Okay. And what we want to do in our open set is we want to enqueue the start tile with a distance of 0. Basically, the priority in this is going to describe how far away from the starting tile is the tile in the queue. And all we do is we insert the very first tile, our original tile, in here, and we say that it's got a distance of 0 from itself, which is clearly true. Then we're going to have... I wish the copy and paste in this worked properly. It's so frustrating that it doesn't. We're going to have a dictionary describing where we came from. Apparently. And we're going to have 2 types of score costs. God, I can't believe it. That's one thing working on the Mac. The mono behaviors copy and paste is not horribly, horribly busted. And I can't believe that's something that's never been fixed. So we're going to have a G score and an F score. These represents the cost it takes us to walk along the tiles, both the actual cost to date as well as an estimated one. G-score is how many actual tiles it took for us to walk from point A to point B. So in this case, the cost to get to our start tile is indeed 0. It's going to be the same as the priority queue, I think, most of the time. The priority queue one, I think, will include the estimate. F-score includes the estimated cost of getting to that tile. Which, this is the whole power of A-star. A-star tries to guess what it thinks the total cost will be in the end to get somewhere. And that means we get to use our distance functions. Now, so we're going to have, I think here, cost estimate was just set up as a delegate, right? Mm-hmm. Which we could still do. I think to simplify things, we won't do it. We can reorganize this to be a delegate later on. But let's say we've got something. Turn off caps lock. We're gonna have some sort of function called cast estimate, and it's gonna take 2 tiles. Source dest, and return the estimated distance from source to destination over here is going to be its goal. So we're going to feed it in first the estimated distance from the start tile to the end tile, assuming that you can walk just in a straight line is basically what this is going to be. So this is going to be returning something. Now, how do we get the cost estimate? Well, the cost estimate is the distance from point A to point B. Yeah, maybe we will go ahead and make a sort of a delegate thing. So we'll have to pass in some more values over here, but that's okay. Because we have, for our hexes, we have a helper called distance, right? The distance from point A, from one hex to another, we can return that as a value. We've already got that function in existence, and we want to use that function there. So I think we are, in fact, going to ask, when you set up this A star, one of the things you're going to have to pass to it. So let's go and organize this a little bit differently here. So we'll probably define that as part of QPath. We're going to list a public delegate, which is going to be our cost estimate function. This is, we're defining the delegate over here. Which this is going to be a function that returns a float and requires a pair of iPath tiles. Like this. So we've defined this, and we're also going to say when you are trying to find the path from A to B, one of the things you're going to have to do is provide a function to all this that is going to be the cost estimate delegate function. Cost estimate func. You're going to have to pass when in there, and likewise, you're going to have to pass that to our resolver. Our resolver is going to want to know the same thing as well. I can close this window here and say over here, we're going to need that info. Otherwise, we cannot go. And we will store that here. And the same thing, we're just going to go ahead and say this dot that is equal to this over here. So then when we do the cost estimate, instead of writing our own, we're just going to call this cost estimate func. We're going to pass it 2 tiles and do that. So that's all. All we know, we don't know what this function does or where it came from, but we know at this point we have some sort of function that will return a float, which is the estimated cost from point A to point B. And what it means is when we go and we do our path operation, so let's say, let me just make a little dummy example here, right? Void dummy pathing function. This is just here for an example. What it's going to do, it's going to call qpath.findPath. So it's going to want our world. We have a reference to that over here, I think. Well, we have our current hex, and our hex has the hex map in it. That's the world. The start tile is going to be our current tile. The end tile is going to be some other tile. We'll just pass the same one twice just so that it's got some legal value in there, even though it makes no sense to go to the same one. And for the cost, the unit, unit is ourselves. Then a couple of tiles get passed, and then it wants a cost estimate function. Well, we can say, listen, you're just going to be using hex.distance. The hex.distance function, that's going to be the estimate function over there. And if we try to compile this, cannot convert method group to cost estimate delegate. Why? Because the signature doesn't actually match 100%? It might be because the signature doesn't match 100% over here. Because it's 2 hex things. Although, why not? If I went and made a temp function here. Is it not public? No. Public delegate, cost estimate delegate. CED is equal to an anonymous function that takes a IQ path tile, A, another IQ path tile B. And what does it do? It actually calls hex.distance AB. Using QPath. Oh, can I just do this? Why did I have to run that twice? Can lambdas not return anything? I feel like I'm going a little bit crazy here. Oh, it's... Alright. Yeah. Right, it's definitely confused about the namespace there. Why doesn't someone in chat's properly got it for me? Don't use the keyword return for the syntax, just have it return a thing. But I'm still just confused why it's not happy with hex.distance. Cannot convert from method group. But doesn't it have the same signature? I'm going to try forcing something in a stupid way, but if we force a cast here, so you're okay, and now this is okay. Really? So now they have the exact same signature. Because this takes an IQ path tile, another IQ path tile. Right, it's because this function doesn't know. It doesn't have the same signature. It's going to be trying to pass an IQ path tile. It can't guarantee it's a hex. We can assume it's a hex at this point. All right, well, instead of doing this, which I feel is stupid and awkward, is let's... Do we want to add it as part of the interface? Because what we could do is something like cost estimate. Just call it cost estimate over here. And you are just going to return. So we can return this back to where it was. So we will leave the distance function untouched. And have this thing just return distance, where we assume that AA is a hex and that BB is a hex. This feels sloppy and weird and not at all what I want. I want to stick the distance function into the IQ tile interface. Well, that's basically what I'm doing here, is I'm going to probably specify that cost estimate is part of the interface or something like that. We'll leave it be for now. But anyway, the upshot is, now instead of doing funky conversion shit, I can just say, listen, hex has got a cost estimate function from hex A to hex B. Takes these IQ path tiles. It assumes we're all working with hexes and doing this. This is not a good and correct way of handling it. It's going to work. That doesn't mean it's, you know, awesome. Distance, not display. There you go. It's going to work, but it feels fluffy and unsatisfying. Still, anyway, then we can go back over here. So we've got a cost estimate function. That's going to be great. All right, I think at this point we're getting to the point where the A star is going to have all the information helpers that it needs, but maybe not quite yet. So our main loop is going to be, what I'm going to do is I'm going to copy and paste here a whole bunch. Fixing a few things because these are path tiles. Isgoal, we're going to come back to you in a second. This was some benchmarking code that we're going to get rid of. You are an IQ pile. Path tile. We're going to have to fix this edges reference over here in a second. So neighbor is literally just the neighbor itself. Pathfinding cost, yada, 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 yada. Hey, I want to say a great big thank you to all the June Patreon supporters and these Mic Check supporters. We've got Yukofin, Eric Sumner, Tiburon, Mighty Mix, Pavel Zdanov, Drazion, Michael McClintock, Aaron Toyson, Craig Mortel, The Not So Evil Engineer, Julien Auger-Lafont, Marius Fieldvold, Speedy Savant, Valiant Cakeveen, Thomas Oberson, Jason Yanity, Stephen Bonnerman, Kale the Quick, and Neil Blakey Milner, and absolutely everyone who watches, shares, favorites, and subscribes to these videos. Thank you so, so much.